So this is going to be a talk about discovering the technology behind the Heretic. The Heretic specifically being the demo that the demo team have shown and was shown in the keynote. And a lot of this talk is basically I'm going to go into all the nitty-gritty details. Well, not all of them, because that would be like a 20-hour talk, but a lot more specific details than was shown in the keynote earlier on. So a lot of editor stuff, because I like showing stuff in the editor, and some explanation and things like this on workflows and stuff like that. So it's a lot of an art safari of just showing some pretty stuff and saying how it was made. We obviously don't need to watch it again, because it's still kind of fresh. So if anyone didn't go to the keynote and is watching this talk, they might get very confused very quickly. So yeah. My name's Andy. I'm a global content evangelist. My parents think I've joined a cult with that title, and I sort of have. I'm based in the Unity Technologies Copenhagen office. So there's a lot of R&D and a lot of features like prefabs and graphics and shader graph and things like that are made from that office. So it's super cool to work with them, as well as the demo team, or part of the demo team. And I'm also on Twitter where I just share shaders and I complain about stuff like Brexit. So a lot of the topics I'm going to talk about, I'm going to go more in depth, but other things I'm going to skim. So I'm going to talk about the timeline structure of the project, because they use it very heavily. The pipeline for creating the results of the realistic digital humans. I'll talk a bit about HDRP lighting and volumes, although that was shown in the keynote, so not as much. Talk a little bit about the Alembic usage and their pipeline that they used to create this. A couple other topics also showed earlier on, and also how some of the procedural VFX were created, specifically the wire robot called Boston, and that takes the form of a bird and takes the form of a glove and these things, but also the procedural effects, VFX for creating that warp transition as well. So I'll talk a bit about those and how they're made, because those are actually all real time, and you can move a slider and play around with the bird's wings and stuff like that. It's super fun to show. So obviously, we have this demo team at Unity. They're currently it's being recorded, so they're gonna get annoyed that I get the number wrong. I think there are about 12 people, maybe a bit more, maybe a bit less, based mostly in Copenhagen and Stockholm. They worked on a variety of different projects, and they always try to kind of do these crazy projects and sort of raise the bar of what Unity can do. And the Heretic is their latest thing. They're actually working on a part 2 of the project, which is going to show more bits and pieces, which is going to come out, I think, later this year. So the first thing they wanted to tackle is realistic digital humans, which is something they haven't really approached in any of their previous projects or in other big demos at Unity. And they wanted to tackle this for a number of reasons. One is their previous demos had like a robot and a god covered in face paint and or body paint and things like this. And they were kind of shying away, but now with various new graphics tools, they wanted to really approach that topic and focus on how we can solve this in Unity and to create humans. So they're from pretty much the beginning, their concept art looked like this, and they knew they wanted to have a character that moved around the scene and interacted with different things in the story, and have a little bird companion or a white hawk here in the corner. So this is kind of like the high-level overview of their data pipeline. So they actually found an actor, and I think the actor was actually once henchman in a James Bond movie, which is pretty cool. So they captured the actor's performance of them talking and doing different things. And they captured 2 sets of that data. And they found that they did this to basically find out the best mix of processing different data forms for the animation. So the first one is 4D capture of the cinematic. And the 4D capture is basically kind of like photogrammetry, but every frame. So every frame, it's basically rendering out a mesh of the character's face at that point. And they did this for a couple of different reasons. The first one is photogrammetry gives you a very good shape around an object. So if you see a photogrammetry scanned like log, then you know it kind of looks like the log. It's got that shape of a log and things like this. So they basically did this for like every frame. They have like a mesh for the face in the original data capture as the character is speaking, especially in this close-up shot. And there are pros and cons to this. The pros are you get really nice shape, consistent shape structure. So for example, when a character smiles like this, normally in games, they're kind of like ducks, where like the mouth moves, but then everything is like very static. Whereas instead they wanted when the character smiles, the whole face kind of pulls with it because the skin is all kind of like one big wrap around the skull. So the face scan basically gives you that detail. So you get extra detail of the shape, the blood flow, and things like this. So as he opens his mouth, you get all the creases and the wrinkles and things like this, or the shape of the wrinkles. So they captured that 4D data. The next thing they did is they also captured these things called fax poses. And there's lots of sheets and things online, and I'm sure Infinite Realities also have some information on their site. And basically, they then captured extreme poses of the character's face, so like an extreme smile or an extreme frown. And these are kind of then converted into kind of like blend shapes. And the reason why they did this is because the 4D capture data basically doesn't get you a lot of the specific pores or specific texture data. Again, photogrammetry isn't perfect. You scan and you get the shape of the object, but you still get some fuzziness. They didn't want a fuzzy face. So using these fax poses, of which there's sheets and guides, basically they were able to get all that extra micro data. And then, of course, there's the great cleanup phase. So once you've got your data, such as your photogrammetry data of the face, they had to go in and clean up any extra scan pieces that basically didn't make sense. And they used this Russian 3D scanner company to process a lot of that data very quickly. And they use this tech called snappers, which they use for pretty much all their projects, to basically convert that fax poses into basically blend-shaped data. And then after you've done all that, it's not just after you've done all that, there's obviously a long process, but this is like the obviously high-level overview. You then combine that data into Unity on the other end. And this is being recorded, so this slide can be referenced later on with these links as well. So the combined results then get you some nice in-engine tech, nice in-engine results. So on the left, we have it looks like he's auditioning for the Blue Man Group. And this is basically just the mesh-only data, no texture data. And this is using the Unity lights and shadows in the project. And you can notice here that we can kind of tell the character's sort of half frowning because you get that embedded data across the top of his forehead, but also how he's smiling, you get all the creases along his face. And the one on the right is with the textures also combining it from those fax poses. Now there's something very obvious. It looks like a rubber mask, like a Halloween mask. This isn't part of new Unity swag, unfortunately. And he's missing some eyes, but he's also missing some teeth and his tongue, and also facial hair. And the reason because is in the data, I'll leave this slide out. This was a lot of fun to make. So basically, in that capture phase, you're basically getting the wrap of the face, but you're not getting things that aren't part of that scan. So you're not getting eyes, you're not getting teeth and tongue and things like this. So what the team actually did is they made a separate attachment system, which basically they authored like the eyes. Basically, I just turned off the skin. This isn't like a skin rendering bug, which is famous in some games. I'm not going to say. You can obviously Google that. And you can see here you've got the eyes and the teeth, and also you have like hair, but you can't notice it as much because he's only got some stubble and some eyebrows. And basically, they created those attachments separately. And creating those attachments separately, they then fixture them into places, actually using the new dots technology. So every frame as the character is kind of talking, basically it's calculating the triangles and then repositioning things like eyebrows and eyes to those places. And the reason why they did this instead of doing kind of like, oh, we'll just child the eyebrow here and then it's fine, is because, for example, when the character frowns, then the eyebrow needs to bend as well with the shape of the face. So it's pretty cool that they leveraged the dots technology of the job system and bursts to basically calculate face data rather than what we normally show, which is like, oh, here are a million buildings and things like this. So they used it in a very different way, and you get this very fun image. So HDRP shaders. So they actually took a lot of the technology that HDRP brings with shaders and took those shaders and either extended them or modified them or basically used all that text. So with HDRP, you now have diffusion profiles, and you also have some settings for things like thickness maps and also translucency. And they basically took all those shaders because, I mean, you can just grab them from GitHub and slightly modified them. So they used the stack lit shader because they were able to stack up subsurface scattering and other types of graphics features on top of each other. And I'll jump over to the editor and show you some of that in a sec. For the eyes, they made their own custom eye shader, but they're eventually aiming to roll this out as part of the offering of Unity. And they also have some eye renderer tech, some scripts to tweak some things, and I'll show you that a bit later. And I already showed it in the keynote, but they also use the Shader Graph's hair master node. And I joke that it's not a good shampoo model, but the creative director of this project made that joke, so I've got to say it. But for his eyebrows and things, they basically use the new hair master node. Another important aspect is the lighting setup. So on the left is just the environment lights of the corridor, which the environment artist set up. So they set up lights coming through the back of the corridor, through the door. They also set up lights sort of positioned in the environment. And obviously, you're going to get this much darker result. So you get some nice shine on the left-hand side of his face, and obviously, you get the subsurface scattering through his right ear. But you don't have as much detail as you would like. It's a bit dark. People start complaining, like the Game of Thrones episode, which was too dark, apparently. I haven't seen the new one, so don't spoil it, please. So what they did is they actually used light layers, which allow you to specify certain objects to receive light from certain lights. So basically, Gawain, which is the name of the character, has his own character light rig, which is basically a series of spotlights and point lights that kind of follow his face around. So as he walks around, you have this sort of light rig around his face, and they're told to only point towards these specific objects. So you can now say this light only casts to this light layer, and this object only used this light layer. So you can actually do more specific details. So here he has a couple of spotlights and point lights on the left-hand side of his face. And obviously then combining those things with the environment lights, so the environment artist can still set up the corridor lighting, and then this face rig, you then get this finer details. Oh, we'll go on to that bit a bit later on. So here we have, obviously, Gawain's face. So what you'll notice in the shader on the far right of the inspector is we have a lot of settings and values which are being pumped in. And a lot of these settings and values are then hooked into HDRP's shader system. So if I zoom in the face, I'll do some fun stuff like let's increase this one. Let's make them really old. So this is basically just increasing the normal map, but then you're getting the, we now have old grain, moldy grain. I know the demo team are going to watch this and get really mad with me, but it's fine. We also have some other settings. So we have thickness maps. So this is basically Gawain's face. This doesn't look like this looks like a horror mask. That one's a bit better. Yeah, that doesn't look like anything. But basically, there's thickness maps to define how thick and how dense certain parts of the face are. So the ear has a certain value of thickness to allow light to pass through it. I mean, realistically, light doesn't pass through our whole skull and our whole face, but you're going to have some areas, such as a nose or ears, which stick out a little bit more. So you're going to want light to pass through them, such as the corner here. And Ashley's giving a talk after this a little bit about how these different things are set up. Just putting her on the spot. So I talked a little bit about diffusion profiles. So let's have a look at these. So diffusion profiles in HDRP are basically these preset assets. So you can determine things such as index of refraction of the skin. So if we increase the index of refraction, you see that light is being captured a little bit better and is transmitting a bit better around the face. So the whites of his eyes are a little bit more wet. So let's tone that down. And obviously, we move it to bottom. We don't have as much influence from the light. We also get some remapping values, which don't seem to be doing anything, but that's fine. And we can also set things such as the thickness of the object or the thinness of the object. So the thickness of transmission would apply to, say, like face, where you have sort of thicker parts, whereas the thinness would apply to something like leaves, where you look through a leaf at the sun and you're going to see some light transmitting through it. So they basically use this for the skin of the character. Now, I already showed the eyebrow using shader graph, but what I'm actually going to show instead is his jacket fur. So I didn't show this in the keynote, but it's fun to see. So here we have his jacket fur that's along here. This is actually created using shader graph as well. So I can change some things, so I could basically increase so I can make him a bit more fawn style. Yeah, I know what Happy Days is. Someone shout out a color, any color? Pink. People always say pink just to show magenta. you know, like, yeah, he's pretty badass. Obviously, he's now doing the DreamWorks face, but I mean, this is obviously not the artistic direction that they intended, but you can see here that using shader graph, you can expose some settings that you can play around with. And again, Ashley's going to give an awesome talk after this about some more shader graph different things. So they used some built-in shaders, slightly customized them for some extra lighting detail, but also shader graph for some effects. Let's have a look at the eye. So the eye is using a shader, but it actually has its own dedicated eye renderer script, which controls a lot of different realistic values. So you'll see the eye renderer script is controls to like the cornea, the pupil, and things like this. They basically wanted to control different things, so different realistic values, so the scale of the eye. Change of the eye radius is hilarious because it just looks like a demon now. It's become possessed. We obviously have like bent light and things, and whoa. The concavity and things, so he's now got like his eye concavity is different. So basically it's showing that you can still have your shader, which has some shader values, but you can also create kind of a renderer script that feeds a lot of data into the shaders and reference values to then tweak. So they use this to control a lot of elements about his eyes. So let's go to this shot. So I've already talked a little bit about the lights, but I'd like to show you a couple of other things. So the lights also have some settings such as different types of shapes. So beforehand in Unity, you had like spotlights and point lights and things. And we now have some elements such as like rectangle lights, tube lights. So let's take a look at this corridor. And let's turn this into like a tube light. So this is now a long tube light. So everyone's going to put lightsabers in their games now. So that's super cool. You notice it's reflecting as well in the water, which is definitely wasn't planned. And we have rectangle lights, so you can actually set up like great big fill boxes. And they actually use this for a lot of different aspects of the demo. Have these big rectangular lights that kind of as fill lights in the background, especially that opening door shot with the particles that I was showing. Let's go back to the spotlight here and reset its position because I already broke it. So a lot of different elements of having these light settings is obviously these extra graphics features being applied to this environment. So one thing that we've added is this new volume-based system. So if you look to the inspector on the right, in HDRP we have these volumes, and volumes are kind of very generic in that they have a lot of graphics features that you can specify for an area. So we have here for this corridor, we have a volume that basically defines things such as volumetric fog, procedural sky, because you can kind of look outside of the door in one shot. We didn't want the sky to be generic Unity blue. Screen space reflections. So we have the feature so you can basically reflect a bit of the wall in these shiny puddles. And obviously things like contact shadows. So if I turn off contact shadows, you'll notice that the real-time shadows have slightly less detail around the smaller little minute parts that they cast onto, specifically these little pebbles down here. So with the volume system, if I open this up, you'll notice that there's a lot of different settings that I can add. So I can add micro shadows or just shadow settings, render properties. Probably shouldn't have added that because it's now going to do something. Yep. And you can also create your own custom volume settings. So the team actually made their own lens flares for certain shots. So they basically say as the camera goes into this corridor, these are the lens flare settings. And I think they're actually going to roll these lens flares then into Unity. So the team does a lot of R in the R&D part of research and development, and then kind of eventually a lot of their tech and feedback rolls directly into Unity, which is super cool to see. So yeah, you can basically specify volumes per area to define different graphics features and things, such as, in this space, screen space reflections and volumetric fog. So what else is there to show? Probably a lot of other things. I've already shown volumetric fog. Oh, so this is an interesting scene. So at this particular point, Boston, the wire robot, basically destroys loads of stuff. So he goes through and he crushes all those boxes, which is super cool. And he does this, this door tear apart, which is super nice. So it's interesting how they created this. So the actual door tear apart that takes place is actually simulated using simulated using, I think, 3ds Max or Houdini. It's one or the other. So we can see here that scrubbing through timeline, because they use timeline to simulate pretty much everything. This is obviously without lighting, but turn this on. At this particular shot, it pulls the door open. And the way that the team actually worked, with the VFX artists, they already had this corridor set up. So the environment artists had already done their job and already set up this whole corridor. And then with that corridor, Unity has an FBX exporter tool. So they actually used that and exported the whole corridor as it was set up and brought it into a tool like Maya or 3ds Max or Houdini. And then you already have your environment to the right scale and to the right size and all the little details. And then in using Houdini and these tools to create pre-simulated VFX, they're able to use the scale of the environment. So they're like, oh, we already know the corridor's this big, so let's just make the particles to that size. And I'm sure everyone here, including myself, has imported stuff. You're like, oh, it's like the door is now 10 times bigger than my character, so I've got to scale it down. And then, oh, now my character's too big for this ledge, so I have to scale it up, and these things. So it was interesting, they actually took the corridor, exported it, did all these simulations, and then I think they then turned off the corridor and then export the simulations. And then that way they already have stuff like we have here, this like crushes those boxes. It has no regards for historical locations and pulls open this door. So yeah, and I guess an interesting point to go here is that these are simulated using Alembic, which is quite a standard file format in pre-simulated VFX. And they use a dedicated Alembics timeline, which is available on GitHub. And if you haven't seen Timeline, they actually use Timeline to simulate pretty much everything in the demo. And Timeline gives you a linear-based cutscene sequencing tool to place different nodes that turn on and off different things at certain points. And they use it not just for animation and lighting, but they also use it for things like blending cameras or simulating alembics and things like this. So, you know, as you scroll, it's then going to do certain points and reach them. So if I scroll to this point, at this point we want to turn on the coin. So we have these nodes here to determine things such as animation or data related to the coin as he pulls out of his pocket. So let's have a look at this. So I've already shown a lot of the camera settings in the keynote earlier on, but the one thing I didn't point out is that post-processing in HDRP now uses the same volume setting as those graphics settings. So rather than having to juggle a post-processing profile volume and a graphics settings volume, they're now merged. So it means that in certain areas, so like let's say, for example, you go into a corridor in this project, you can set up things such as the bloom and the exposure and all the camera settings, but you could also set up the volumetric fog for this area. So they have a new unified volume tool. So in this specific case, we've got different things that are camera related, like vignette and bloom and things. However, if I go down and go to the add override, I can add lighting to this specific shot and things like this. Another thing that the team tend to do is they tend to customize a lot of different things. So let's switch this back. So as you can see here, they have their timeline dedicated for cameras. And they actually built a tool that basically, because Timeline has an API that you can extend and do different things with. So you could create your own timelines to sequence very specific things. And you can see here we have the built-in timelines. Built-in tracks such as animation, audio, control, which is for like particles and things, and signal track for events. But we also have some extra tracks, so you can actually extend timeline and create your own timeline tracks. So they use the Alembic track, which is on the Unity Technologies Japan GitHub, so you can get that from there. But they also use timeline to do things like switch different camera profile settings. So in different shots, or each actual shot in the project has its own profile settings to say, fade onto this camera, depth of field cut to this camera, and things like this. Which is why when you go into the scene view, you've got some different things out of focus and in focus depending on the camera shots that's currently being simulated. Just looking at time. So let's talk a little bit about Boston. So Boston is the name, the character name for the wire robot. At GDC, someone said, you talked about Boston a lot. Like, what engine is that? And I'm like, no, that's the name of the bird. And they're like, oh, it makes a lot more sense now. I've been Googling Boston and just getting pictures of the of the city. So Boston is the wire robot in the project, and this is actually like the draw over concept art. And from the very early, they basically wanted to have this wire robot, which is kind of like a tool or a companion for the main character to move around the scene. And they wanted the tool to basically form into different things. So they wanted it to turn into tentacles that like opens a door. They wanted it to turn into a bird, bat, demon. It's very ambiguous for reasons at specific points. So it like flies along the corridor. They also used it for that gauntlet shot. It's like one shot, but his glove gauntlet kind of like recalculates. And it would be cool if we got this as swag as well, if anyone from Unity Marketing is here or watching the video. And it also turns into this thing called the dream catcher, where it basically forms that, that spiral. So the problem they had in part of the design was they needed these wires to move around this cinematic because the director wanted it to take different forms. And the trouble is simulating all of these individual wires, and then let's say, for example, the door is now slightly higher or slightly back or things, then they have to resimulate that every time. So actually, Boston isn't actually pre-simulated. It's actually entirely procedural. And you can actually, they built a lot of editor tools, and kind of the story of this is you can create editor tools in Unity to control different things, to actually move Boston around the environment. So they basically have these transforms, and Boston actually flows along these transforms, and you can move around and play with them. So I'm going to jump back to Unity. I love doing this bit. It's a lot of particles. So here we have this shot here where Boston actually clambers across this back wall. And you can kind of see he sort of moves along this back wall like that. If I jump to the scene view, this is where Boston's selected. There's actually a series of points. So he's entirely dynamic. He can move around and take different shapes and forms. And the team basically extended Unity because Unity has editor APIs to make your own tools and things. Because they wanted a wire robot, so they were like, right, we're going to have to make wire robot tech. So here you notice that Boston moves around. So we have these points. These are just basically transforms that he follows. And they also made a really cool twist thing because at some points he sort of twists around. And obviously they have a lot of settings here. So let's, that's, yeah, very, very, very large Boston, or very thin, very, very thin, wiry spaghetti Boston. I'm not going to, part 2, he doesn't form spaghetti, don't worry. It's okay. I'm definitely saying stuff the demo team are going to, yeah. You can tweak the distribution jitter, the clumping power, and kind of the point of showing you this is that you can create all sorts of really cool dynamic real-time tools in Unity and sequence things in a real-time way. So, and we also have things such as the spread. Okay, I've totally broken them now, so let's undo a lot of these different steps. So one of the other things that they desired the wire robot to do is not just fly around the scene, because it would be easy to just set up points and it flows through them, but to clamber to certain parts of the environment. So you notice here that as he comes towards the wall, he is automatically calculating how he sort of wraps to the wall. So this is actually done using a signed distance field. So here we have a I'll just zoom out. So yeah, here's the environment corridors and the big sky fill light. So here we have the corridor that he walks along the walls. And what you can see here is we have this slice. And if I move this slice along, this slice is basically a 3D texture which is baked from the environment. So they took the environment and they set up all the pipes and poles and things. And they basically baked that into this kind of reference texture. So in baking into the reference texture, they basically specify that in the Boston's tech, that when he's close to the black pixels of the environment, then clamber to the wall. When he's closer to the white pixels, then it's less influence. It's basically the influence range. So we basically specify the influence range of this environment, including the depth and all these different things. So that's why when he's closer to the wall or he's further away from the wall, he kind of sticks to it. And another really cool thing is you can use this clambering tech for other different forms. So there's the glove and the dream catcher and stuff like this. So here we have him in his bird form. Obviously I can hit play and he flies. Let's switch back to the main timeline. So here we have him in his bird form. We can obviously step through and he flaps and flutters and these things. And it's exactly the same ideology. We basically have that wiretech, and we can wrap the wiretech. So, for example, we have different layers for his wings. We can, whoa, okay, very thick wings. We can obviously tweak different settings, so we can do the pull strength, so we can actually widen the wings. Let's do the length offset as well. So kind of they made all these tools so they could tweak very quickly and iterate very quickly on how, so now his wings are like really, really wide spread along there. So basically, yeah, they made this tool to specify on the glove, act in this way to the glove, and things like that. The other really cool thing is that to turn him into a bird form, we basically then, they made a 3D texture of like a bird wingspan, which they then animate, because as they animate the bird flying through the corridor, they then have this texture. So they're able to tell Boston to take the form of a bird at this particular point. So timeline then cuts and says, at this point, you're now a gauntlet or a glove. At this point, you're now tentacles. At this point, now use this bird form. So they basically made these pretty cool debug tools to specify the same logic. We have the black areas for where the wires attract to, but the white areas where the wires are not attracted to. That's kind of Boston in a nutshell. And then we have some pretty diagram. I'm kind of running out of time, so I'm going to go on to the next big tool. So the next thing, okay, the next thing I want to talk about is this cave warp, and that's the transition that makes the corridor transform into the cave. And as we can see here, a couple of screenshots of that transition. So this was kind of the big puzzle or the big question. I actually asked if they had concept art, and they said they didn't, which is kind of funny. So they said, oh, so the task was they have this corridor environment, and they wanted to do something real-time with shaders and things like this to convert it into a cave. So how do we take it from this corridor to this cave without doing, you know, a Star Wars screen wipe or a fade to black or something boring like this? How do we do this pretty cool transition or effect? So they actually started looking at logs of wood. I know that sounds very weird, but basically they thought a lot about this kind of idea that if you cut like a log in half, you have all the rings inside, including some kind of design. So here we have this outline of this inside of this tree. And if you stack enough of these up, you then get lots of different slices all in a row. And they applied this technology, applied this slider thinking to this environment because it's kind of like looking down a barrel of a tree. And they said, oh, maybe we could transform it by using shaders to convert it from inside the slices from one thing to another thing. So on the left is like one slice mesh. So they basically made these disks. So they make a disk with this inside cut out, and it looks like this. And then when you take a row of these slice meshes and put them in a row, and this is like a top-down photo, they kind of look like this. But then when you put a camera inside them, you could get something that looks like this. So the whole environment is split up to lots of different individual chunks and pieces. And there he is standing, so you can see for scale. But then the next question was, okay, so we have this one slice, and we have like this corridor of slices. How do we get that data to actually tell it to look like a corridor and then a cave and translate? We know we want to use shaders, because shaders are very powerful when you feed them data to do different things. So how can we get that? And the actual pretty cool thing is they built a tool on top of Unity using the editor API to basically bake the environment to a reference texture. So on the left, we have a top-down view of that corridor. And they basically, we have this green line, and they basically made this tool to basically walk along this path and basically bake at each point of the path the status of the corridor. And then they bake it into this texture. And this texture looks like nonsense if you think about it. But basically, the Y position along the path can be mapped to here. It's 512 long. And then the X position bakes things like the color, the bend, the position, and things like this. The cave, they also baked the same texture data. And it's a bit more obvious here that we have the path of this cave right here. So they basically baked to the texture to use as a reference in a shader. Like shaders normally use normal maps and all these different things anyway. And in Unity, they have this custom render texture system, which allows you to, instead of make a render texture and output a camera to it and things like this, what the custom render texture lets you do is write shaders for different simulations. So you don't necessarily give it a camera or some data to output to. You can instead kind of do cool mixing and stuff before it's used in the scene. So using custom render texture, which has been out for a couple of years, I think, they basically input both the corridor and cave reference maps. So they have both the corridor in its corridor state and the cave in its cave state. And they made this slice controller, which controls the twist values, and I'll show you this in the editor in a second. And it basically mixes all that together, and it outputs to the shader of each of these slice meshes the position they should be in, the color, and the normals. And it's pretty cool that this texture represents all that data inside that corridor block, and this one for the cave as well. So this is what it would look like when we have, for example, the colors applied to it as well. So we have that one slice mesh for, this is when it's in the cave form. And this is kind of how it looks when you move the camera out of the perspective that it has. You have all these individual slices. So let's jump over to the editor and have a look at how that looks. So, whoa, okay. Okay, let's switch to the scene view. So here we have this, this corridor, and let's actually zoom out. So you notice it's that big barrel that I was telling you about. Whoa. And you notice that as I scrub through in timeline, it's basically mixing the values between the corridor and the cave. So if I pull this here, back to here, okay, it gets very small. So notice that all the slices are then reshuffling from one reference texture to the other reference texture and back again. So if we get to about halfway point and fly down this corridor, they basically made a ton of values. So this slice screen thing is taking that slice mixer, that's the custom render texture. It's taking those two sets of the baked slice data. And they basically just spent a long time making a lot of values to tweak a lot of different things. So if I move this mix, you can basically shuffle the mix of the points. Let's do the twist. So we can now like twist these back and forth. Let's see how that looks in the scene view. So basically we can twist it around as well, which is super fun to play with. Another thing they implemented is smoothness. So if we increase the smoothness of the corridor, it's now more of like a smoother bend. So now we go from corridor to the cave. And it's a smoother transition. And they also added like noise because, I mean, everything looks better with noise, right? So we can now do the wrap with some extra noise. So kind of the point of me showing you this is that actually, it's funny, the Boston wire robot and the cave thing isn't really using any new technology. Actually, this shader is actually a HD shader, which is, so again, it has all the lighting and all these different things. But they're using just basically extending the editor to build all these tools directly inside the editor without having to pre-simulate them, and you get all these extra effects like this. They actually have a cool video where they hooked up a lot of these sliders to like a MIDI board, and they were able to move these sliders and twist the corridor in lots of different ways. So now you can twist the corridor to look a little bit like this. And I'm kind of out of time, but I just want to show you one last thing. So after this video came out, everyone said, oh, that backdrop is just like a big billboard or a big quad, right? And I'm like, well, actually, it's not. It's actually like, I think just the trees are the billboards. So, I mean, but they're far enough away and like some of the clouds, but I thought I'd show you that a lot of these elements are actually 3D meshes which are instanced in this big outdoor environment, including this big throne room temple or whatever it might be called. And I basically ran out of time, but one of the cool things about the project was because all the lighting is actually real time, I was pulling the project from SVN constantly, and then eventually I pulled it one day, and this was the day before inside like a big cave, kind of like Zion from The Matrix or something like this. And then I pulled it, and then the cave wall was missing. I was like, did the project break? Like, what's going on? They're like, no, we just wanted to change it. And this was like a week before shipping. And then they just removed the cave and then made everything into a directional light and make it all kind of outdoors. So it's kind of funny that they changed this last minute, and it's kind of one of the main visuals of the whole project. Yeah, it's just a funny story. And we obviously have the bird and wires and bird form flying into the distance. So I'm actually out of time. I wish I could keep talking about this. I want to write more blog posts and videos and information about how these different things were made. I'm not sure if we have time for questions. Maybe? People are shaking their heads, so I guess not. But I have an email and a Twitter, just like everyone. So if you have any questions, I'll also be hanging around the rest of the conference. I'm giving a talk later on about the FPS sample project. a similar thing showing some stuff in it. So if you want to come to that, that's cool. If not, grab me and we can talk about any number of different things, except UK politics. So yeah. So yeah, thank you. Cheers.